Okay, hello everyone. It's Mrs. Golson here, getting ready to review what we have been working on for the past week. And since we are in 7th grade, it's going to get a little bit tougher. Everything is an extension of what you have learned before. So let's remember a unit rate. A unit rate is the ratio for 1 unit of a given quantity. A student described it yesterday as the amount of something for every one thing. So here's some examples here. 60 miles in 1 hour. It tells me how many miles I'm going to go in just 1 hour. $14 per day. And I have here in red, this is 1 day. So when I ask you, okay, if I'm talking about the dollars per day, how many days am I referring to? You should say just 1. That is the unit rate. Think of some other examples of unit rates. Okay, here, let's look at the first example. Up here it says the pretty one. And what I mean by the pretty one is that we are so used to our unit rates being so simple and easy to figure out. But let's just review how we would do this. Example 1 says Cheryl biked 21 miles in 4 hours. What is Cheryl's speed in miles per hour? So this section right here, miles per hour, just like the previous board, is asking me how far can Shelly go in just 1 hour. So I'm going to set up a proportion. That's a vocab word that you may not be familiar with yet. Some of you probably remember from Miss Deere last year. But a proportion is just 2 equal ratios. So I know this rate here is 21 miles in 4 hours. And this indicator means I'm looking for the unit rate. How far did she go in just 1 hour? Well, I look at the bottom here and I say, started off at 4 hours and I'm trying to get to 1. So it must have scaled down. The number has gotten smaller. And we can't say subtract 3 because I don't add and subtract with ratios. I scale up or down by multiplying or dividing. So what do I do to 4 to get to this 1? I divide by 4. And remember, with ratios and fractions, whatever I do to the bottom, I'm going to do the same thing to the top. So I'm just going to divide this really quickly. How many times is 4 going to 21? I'm going to do my math over here. 4 times 5 gives me 20. Got 1 here. Add a decimal. I'm going to add a couple zeros here. Drop a 0 down. 4 goes into 10 twice. Up. Bring your decimal up, Mrs. Golson. 4 times 2, 8. Subtract. I get 2. Bring my last 0 down. 4 goes into 20 5 times, leaving me without a remainder. This is the pretty one. So my unit rate is 5 25 of a mile in 1 hour. So that's how far Shelly can bike. This is my unit rate. But now, as we were saying, 7th grade, we're going to see some things that are not so pretty and not so easy, like Cheryl's biking. So the not so pretty unit rates. Now you're going to see complex fractions. This definition is very important, and I see a little bit rubbed off. So I'm going to grab my red marker and fill it back in for you. Complex fractions. Here's a definition for you. If we need to pause the video, we can pause it. So complex fractions are fractions that have a fraction or a decimal in the numerator or denominator, or in both the numerator and denominator. This face is saying, say what? Because you have not seen a complex fraction before. We may have tried to write them in the past, but your teachers have probably told you, don't write your fractions like that. But now you can, because remember what the fraction bar means in a fraction. Say what? Okay, so complex fractions can look like this. Here are some examples, 4 of them that you can put in your notes so you remember what a complex fraction is. So here is 1/2 over 3/4. What problem is this really? Think about what this means right here, this fraction bar. Remember, this thing means divided by. So this is really 1/2 divided by 3/4. Dividing fractions is going to sneak back up on you throughout this whole year. What is this really saying? Take a minute to think about it. This is really 2/5 divided by 5. This problem is really, this is 3 over 1/4. This problem is really 3 divided by 1/4. What is this? I've got a 2/10 over 20. Remember, this fraction bar means dividing by. I'm going to divide. So this is really 2/10 divided by 20. If we remember back to first quarter, division is really multiplying by the multiplicative inverse. Or if you remember, keep, change, flip. So 1/2 divided by 3/4 is really 1/2 times 4/3. 2/5 divided by 5 is really 2/5 times 1/5. 3 divided by 1/4 is really 3 times 4. Catch that? And this is really 2/10 divided by 20. This is 2/10 times 1/20. And recall that 2/10 as a decimal, when you read the decimal, you're saying the fraction. So 2/10 looks like 2 over 10. All right, it's time for you to do it. So here is a problem that has a complex fraction. This example is in your notes. Let's read it together. Maya skates 1/4 of a mile in a half an hour. At what speed does Maya skate? I can take two approaches to this problem. The first one, I'm going to do it like we are used to, using a proportion. So here I have my rate, and I'm going to write it just like I see it. So she goes 1/4 of a mile in half of an hour. So this is a complex fraction because I have a fraction in the numerator and the denominator. So the question is, at what speed does Maya skate? So it's looking for her miles per hour. So I'm looking for how far does she go in 1 hour. So if I look at 1/2 and I look at this 1, am I scaling up where the number is getting larger, or am I scaling down when the number gets smaller? I am scaling up because 1 is going to be bigger than 1/2. So 1/2 times something is going to be 1. So what number can I multiply by 1/2 to get to 1? That number is 2 because there's 2 halves in one whole. So whatever I do to the bottom, I do to the top times 2. So 1/2 times 2, or I'm sorry, 1/4 times 2, going to multiply. Remember, 2 goes over 1. 1 times 2 is 2. 4 times 1 is 4. 2/4, when I simplify it, is 1/2. So Maya can skate a half a mile in 1 hour. That is using the proportion method. I'm going to erase this. Okay, second approach I can take is I can set up a rate table. And I know you remember these from last year from Ms. Deere. So if I make a table, my 2 units are miles and hours. let's make some spaces here. Like that. Here in the problem it's telling me Maya can skate 1/4 of a mile in a half an hour. So I'm going to start with my first rate. 1/4 of a mile in half an hour. And it's asking me for the unit rate, so I'm trying to figure out what can I do to get to 1. So 1/2 times 2 is 1. Do the same thing here. And of course we have 2/4, which is 1/2. So this is giving me the answer the same way. So this is 1/2 of a mile per hour. That's the unit rate. Pause the video, stop, ask any questions now if you need to, students. Okay, let's look at one more example. All right, Damon, he can read, and this should say, Damon reads 1/8 of a comic book in 2 days. Hear the rate, 1/8 of a comic book in 2 days. He reads the same number of pages every day. What part of the book does he read in 1 week? Got some things to think about here. Pause, try it on your own. Okay, so let's look. So we know that Damon can read 1/8 of the comic book in 2 days. Now it says, what part of the book does he read in 1 week? 1 week. So I know this is the unit rate, but in the rate, it did not give me weeks. It gave me days. So the question I have to ask myself is how many days are in 1 week? It'll still be the unit rate, but how many days are in 1 week? And we know that that is 7. So I'm going to go ahead and put 7 days here. If I put weeks here, my units would not match. And I want my units to make sure they match. Days at the bottom, comic book at the top. So now I ask myself, am I scaling up or scaling down? I'm starting at 2, getting to 7. That means I'm scaling up. I'm going to multiply by something. So what number do I multiply by 2 to get to 7? I know that number is 3.5. If you want to check it, here's my math. 3.5 times 2, 7. So whatever I do to the bottom, I'm going to do it to the top. Now, crazy, because I got a fraction multiplied by a decimal. Well, I know that this is 3.5 or 3 5/10. So I'm going to use my scratch pad down here. 1/8 times 3 5/10. I know that when I change this into an improper fraction, I got 10 times 3, which is 30 plus 5, 35. So this is 35 over 10. Now multiply straight across. 1 times 35, 35. 8 times 10, 80. Simplify. I can put that in simplest form. Looks like my GCF is going to be 5. So let's say 35 divided by 5 gives me 7. 80 divided by 5 is going to give me, that's going to be 16. So Damon, he reads 7/16 of a book in 1 week. Another approach that I could take with this, I can go back to my trusty rate table. Take a minute to look at that. I'm going to erase this. Okay, so make my table. What are my 2 units? My 2 units are the comic book and I'm just going to put comic and days. Alright, so they gave me the rate of 1/8 of a comic book in 2 days. So when I do a rate table, it's helpful to have the unit rate so I can use that unit rate to find other rates. So I'm going to leave a space and I'm going to put 1/8 of a comic book in 2 days. So I need to know if he reads 1/8 of a comic book in 2 days, how much does Damon read in 1 day? How do I find the unit rate? I divide. So let's divide 1/8 divided by 2. Going back, this is 1/8 times 1/2, and this is 1/16. So the unit rate that Damon reads is 1/16 of the book in 1 day. We have 2 days. Now the question says, what part of the book does he read in 1 week? So I'm going to extend my table so that it has 7 days. 1, 2, 3, 4, 5, 6, 7. Fill in the table. Count by 1/16. So this is 1, 2, 3, 4, 5, 6, 7. Now this is 1/16 on the first day, 1/8, which is 2/16, so we didn't skip that one, in 2 days, 3/16, 4/16, 5/16, 6/16, 7/16 in the 7 days, which is 1 week. This is the same answer that we got from before. Very good. Pause the video if you have any questions. Last one. Okay, 1 lap around a dirt track is 1/3 of a mile. It takes Bryce 1/9 of an hour to ride 1 lap. What is Bryce's unit rate in miles around the track? Okay, take a moment, think about this one. Okay, so we know Bryce, it takes him 1/9 of an hour to ride 1 lap. And we know that 1 lap is 1/3 of a mile. So that means that Bryce can go 1/3 of a mile in 1/9 of an hour. There is that complex fraction. So the question is, what is Bryce's unit rate in miles around the track? So we want to know how many miles can Bryce go in 1 hour? Okay, now think. 1/9, is it bigger than or smaller than this 1? It's smaller. How many 1/9 are in 1 whole hour? There are 9. So let's take this, multiply it by 9. Whatever I do to the bottom, do to the top. So now let's do our scratch work on the side. 1/3 times 9. Going to pop the 9 over 1. This is going to be 9 over 3. Simplify that, which is going to give me 3. So he can go 3 miles in 1 hour if it takes him 1/3 of a mile and 1/9 of an hour. Let's take this same problem and approach it with a rate table. Okay, I'm going to write my answer down here that we got before, 3 miles per hour. Alright, let's make a rate table. My 2 units that I'm comparing, miles hours. Okay, so we know it takes him 1/9 of an hour to ride one third of a mile. So he's going 1/3 of a mile in 1/9 of an hour. I want to know what's his unit rate, or how far can he go in 1 hour. So since I know my hours are divided up into ninths, I'm going to need 9 of these sections. Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. Okay, so let's fill in our hours first, because we know we need to get to 1 hour, which is 9/9. Following me? Okay, so let's fill in 2/9, 3/9, 4/9, 5/9, 6/9, 7/9, 8/9. Then we've got 9/9. Okay, so this is counting up by 1. So that means for every 9th of an hour, Bryce is going to go 1/3 of a mile. So here we go. This is 1/3, 1/3 plus another 1/3, 2/3, 3/3, or 1 and 1/3. Ooh, Miss Golson messing up there. 1 and 2/3, 1 and 3/3, which is really 2 and 1/3, 2 and 2/3, 2 and 3/3, which is really 3. So 3 miles per hour. Got the same answer as before. Complex fractions. Little bit tougher in 7th grade. Remember, check this video out on mathwithgolson.weebly.com. Be yourself, because those that mind don't matter. Those that matter don't mind. Cut.